Hi there. So this video, we are going to cover loans. So I will jump right in to our notes. Get out of the way, zoom. Okay, so loans are a situation where you owe a certain amount of money, but you can't pay it back all at once. So what you do is you pay back a monthly payment, but as long as you still have outstanding an amount on your loan, you're still paying interest on your loan. So let's show how this looks with the example of your friend who has borrowed money and has set up essentially an annuity with you, where after the first year, he's been a bum, he's now owes you a whopping $4,000. Let me get my video out of the way. Okay, a whopping $4,000, $257.61. But he's had a turn, he's repented, he's had a change of heart, and he is got a job finally. And he says, I want to pay you back. Okay, so he says, I'm going to pay you back in a year, the same amount each month. And you say, yes, you can do this, but you still owe me interest each month on what you still owe me. So he agrees to this. And so you work together to set up a formula, a recursive formula for the situation. So the initial amount he owes you, P naught, this is now the amount he owes. Initially is now reduced. This is the monthly payment. Each month, he reduces the amount he owes you by amount D, which is actually unknown. But you know that each month you're still getting interest. So interest is 3%, and this is the previous month's balance. So you see the current balance is the previous month plus interest minus the payment. We've made a payment each month. And so again, this annuity formula is a little tricky to get the explicit form, but using some tricks from Calc 2, we can derive this explicit formula. Okay, so here's an example where he decides, hey, I'm going to pay you back after n equals 12. So put in 12 here. And this is what a bank will do. It says, okay, here's the formula for how you owe me money. This is what you owe me. I'm going to now calculate your monthly payment. And so to do this, I'm going to show you how I would do this using a calculator. So we got D times, make my D a little better there. Here's the formula written out. D times 1 minus 1 plus 0.03. That's the monthly interest rate to the negative 12th divided by 0.03 equals, oh man, I'm not a fan of OneNote. It's always jumping around on me. Okay, 61 cents. So how do we solve this formula for D? D times this value here. Well, what you can do is find out what this value in parentheses is. I'm going to make that colored. We'll find out what that is. That's equal to 4,257. And then we can divide both sides by that number. Okay. So let's go to my calculator. Because these calculations, like before, can be a little tricky. There's lots of places you can trip up on them. So I'll illustrate how we can put these numbers all in effectively. Okay, so we have 1 minus, oh, I forgot a parentheses here. There should be a parentheses on this number here. And if you forget one parentheses, it messes it all up. Okay, to the negative 12th divided by 0.03. Okay, so we get a number 9.954. It's good if you can leave that number as exact as possible. So I'm just going to copy paste that number. And what we're doing is total amount 2,057, 257, 61, divided by that. Divided by 9.954. So that cancels, giving us what D is, the monthly payment, is $427.73. We'll always round to the nearest cent for financial applications. So that's how you can solve this. It's a lot of different calculations, but we've solved effectively for our monthly payment. And so that means after a year, he'll have paid this amount 12 times. So total paid, if you're curious, paid out to you times 12. Let's just check out what that is. So he will have paid you $5,132. In some sense. So remember the amount he paid you, the total you paid him initially was $300 times 12 was 3,600. So all this math shows you, well, you made some money off of him. After he's finally paid it back after a year, you've made $1,532. So this is how banks work. This is how they make their money, interest. And it's a pretty profound thing, what the effect of interest over time, whether you're taking a loan or you're making an annuity. So I am going to show you the general formula, and we're going to do 2 more examples of this. So here's the general formula. What I did here in this example to make it easier, we had a monthly interest rate, which again led to an annual interest rate of 0.36. So the general formula is going to look like this. Come on, focus, focus. There we go. So D is the monthly payment, or it could be other terms, but virtually all loans are in months. But K, the number of periods, technically it could be something else, but it's usually months. So it's usually 12 months per year. R is again your interest rate as a decimal. And N, the big N, is the length of the loan or the term of the loan in years. So this is the loan formula. Again, it's kind of complicated. We got to use our parentheses judiciously, but let's see an example of how you do this. Okay, so you decide you're going to buy a car, and you can budget $200 a month. That's what you can pay. So that's your monthly payment, your D. And you can afford an auto loan at 3% interest. That's a really good interest rate. Interest rates are good right now for 5 years. And so how big of a loan can you take? Okay. So notice in the formula, I didn't talk about one variable, P naught. That's the size of the loan. So the beginning balance of the loan. Okay, so we want to find P naught. Is D times 1 minus R over K. Oh, I got it wrong here. Minus 1 plus R over K. Good idea to write these formulas out. Someone was asking about that last class. Okay, so we got our D is 250. R 0.03. N is a 5-year term loan, and K is 12. So this is one of a problem where you can put it all in at once. So we got 250, 1 minus 0.03 over 12. I keep forgetting. This formula is like pretty tricky. Yeah. 1 plus R, 0.03 over 12. Okay. So practice putting that in your calculator with lots of parentheses. And here is actually that calculation done for us. This says you can afford an $11,000 loan. Once you do that, all that finds are value or initial value of the loan. Like how much you pay initially. And it's that 11,000. So let's do the opposite. Here we found out the amount of the loan. P naught. Let's say we know the amount of loan. Usually you're buying something that you know the amount. And if you can find the interest rates and the term of the loan, you can calculate your monthly payments like we did before. So I want to give you another example of this. So I'm going to set this up. Yeah, this will be a good quiz one too. I'll set it up and you can practice calculating it. Okay, so P naught equals D. Okay, over R over K. P naught is 140,000. D is what we want to find out. The monthly payment, D, that's what we don't know. So we got to do 1 minus 1 plus the rate. Almost always 12 for a 30-year loan. Okay, see if you can practice solving this. Again, you want to find the right-hand side, calculate what that is. So you get 140,000 times D equals something. Then you got to divide by both sides of that to get the loan amount. Okay. And then you'll also practice on the quiz, finding how much interest you paid, which the interest paid is the monthly payments times the number of months, so 12 months in a year, times the number of years, minus the initial amount. Okay, so you can check your work there. All right, I will stop here and we will continue in class. So again, this is like pretty useful to do if you're getting a loan or thinking about getting a loan, to know what the math is yourself, not just trust the salesman, because they can try to pull things on you. And I actually recently was considering buying solar. They told me the amount of my loan and they used that as the amount that I was paying. No, the loan amount isn't what I'm paying. You pay much more because interest is added to your loan. So you got, if you know this kind of stuff, you can be real smart and I really understand what decisions you're making. So good luck.